All right, so I've already stressed in class that to be able to complete a square, you have to know what a perfect square trinomial is. And we've already kind of talked about this, but just a quick refresher, remember perfect square trinomials are guys that have perfect squares in the front and the back, and the middle term is the square roots multiplied together and doubled. So what I mean by that is the front is some term squared, and the back is some term squared. And the middle is those two multiplied together and doubled. So a times b, like the square roots of a squared and b squared, and then doubled. So in this case, it works out because the square root of x squared is x. The square root of 9 is 3. If I multiply those, I get 3x, and if I double it, I get 6x. So this factors into this right here, x plus 3 squared. Because if I actually went through and did my factors in 9 that add up to 6, I would get these two binomials being multiplied together, x plus 3 times x plus 3. And like we saw from the video the other day, just kind of introducing and completing the squares, this c term right here is always half of b squared. So if negative 10 is your b, right, the number in front of the x, and I take half of that, I'm at negative 5, which happens to be this guy right here. And then I square that negative 5, I get 25, which is the part that's on the end, the c term. Okay, so hopefully we should be really good at how this works. And if we're not, let's just take a look at a couple examples just to get really good at it. So to complete a square, we have x squared plus 16x. To figure out that c term, remember we just take half of b. So 16 over 2, which is 8, and we square it, which is 64. And guess what goes on the end in my binomial that's squared here? That is the 8, the half of b. So plus 8. Remember, the half of b always goes in there. So right here, negative 12 is the b. So half of that is negative 6. If I square negative 6, I'd get 36. So we should be really good at this. All right, half of 18 is plus 9. If I square it, I'm at 81. So here's my perfect square trinomial. It factors into this right here. Okay, so just get really good at that. We should be able to fly through this. Half of b is negative 5 over 2, or negative 2.5. And if I square 2.5, I would get 25 fourths, or 6 1/4. Okay, we kind of get in the point here, right? Factored form, half of b is 7 over 2, or 3.5, and if I square 3.5, I'm at 49 fourths. All right, so we could do a bunch of these, but hopefully we're getting the gist of it, right? All right, so why is this helpful with what we're looking into right now? Well, it helps us take standard form and change it directly into vertex form. So how to do that? What we're going to do, we got this y equals x squared plus 16x. What we do is we take this c term and we just kind of pull it off to the side for now. So I'm just going to leave this plus 20 way over here. And then I have to complete the square on my a, like the ax plus bx, or x squared plus bx part. Well, how do I do that? Remember, I take half of b, so I take half of 16, which is 8, and I square it to get 64. So there's my perfect square trinomial, and the reason why we do that is because we want to write it in factored form, which in this case would be x plus, remember, the half of b goes in here, so positive 8 squared. Okay, but be careful. Think about this. I just added a 64 onto the right side of the equal sign. Okay, that doesn't leave my equation balanced. So what I have to do is I have to subtract 64 from this 20 over here, because then a positive 64 and a negative 64 are really 0, right? I can't really add anything just to one side of my equal sign. You have to keep your equations balanced. So your equations have to be balanced. That's why I have to do this. So this trinomial factors into this x plus 8 squared, and then I have to have this on the outside. I had the 20, and I also had to subtract the 64 because I added the 64 from my trinomial, which in this case I'd get minus 44. We'll take a look. Isn't that our vertex form? So the vertex of this quadratic would be at negative 8, negative 44. All right, so that's kind of nice. So it's kind of helpful, right? Let's just kind of try to fly through these then. Remember, so pull off the c right here. So I got y equals x squared minus 18x. This plus 100 is over here. How would I complete this square? Well, I take half of b, so half of negative 18, which is negative 9, and I square it for 81, which means I have to subtract 81 from this 100. And what is my factored form? Well, x, remember, minus 9 squared, and then 100 minus 81 would give us plus 19. So my vertex would be 919. There we go. Ooh, what about this? Okay, this gives us issues right here when we have an a, the ax squared, if we have a coefficient on the x squared. So we start it the same way. We pull the c term off, just like this. So I got y equals, well, the other thing I want to do is I cannot have a coefficient on the x squared, so I have to factor it out no matter what it is. So I'm going to factor out this 3, and then I'm going to have x squared, and then 36 divided by 3 is 12, so plus 12x. And I'm going to leave some space to complete my trinomial here, my perfect square trinomial, and I have this plus 15 on the outside. Right? Why is that plus 15 not in the parentheses? Because I didn't factor a 3 out of it. All right, so to complete this square, just like before, take half of b and square it. So we got 6 squared, which is 36. Here's the tricky part. Do I just subtract 36 here? Well, let's think about this. This 3 gets distributed, correct? Eventually. So it's not really 36 that I added. I really added 36 times 3. So I have to subtract a 36 times 3 from that 15. That's where you have to be careful. Okay, that's kind of the one new thing. All right, so now let's write. Got my 3 out front, and this perfect square trinomial is going to factor into what? X plus, remember that half of b, 6 squared. And then over here, well, what is 36 times 3? 108, and 15 minus 108 gives us negative 93. So there we go. So we'd have a vertex of negative 6, negative 93, and this guy also has a vertical stretch of 3 in this case. So that's where you got to be careful. So we still pull the c off, just like we did up here, right? Still pull that c off, but then you just have to be careful when you complete your square to factor it, that you have to consider this 3 that gets distributed, right, to be able to subtract it from that c term that we pulled off. Okay, so just be careful on that part. Let's do one more of these guys. So we pull the c term off, so we got y equals, remember we got to factor this 2 out. So 2, we got x squared plus 3 over 2x, right, because I really divided by 2. We got to complete that, guys, so I'm going to leave that there with the parentheses with some space, have that minus 1 on the outside. So we take half of b, which happens to be 3/4, and then we square it. So I'd get plus 9/16. And how do I write that? Well, what do I do out here? Remember, I don't just subtract 9/16. I got to subtract 2 times 9/16. All right, so now I can write my factored form. So 2 times, this would be what? X plus, remember the half of b, which is 3/4, squared. And then, I might have to use my calculator here, negative 1 minus 2 times, which is negative 2 1/8, negative 2.125. So there we go, very nice. All right, and we could derive this formula. If we take a look at our standard form, what do? We pulled off the c, there's nothing there, and then we factor out any coefficient. Okay, so when I factor that out, what I do is I take that b term, that number that's in front of the x, and we take half of that, and we square it, right? So I take half of that, so this is really b over 2a, and it gets squared. And then remember, we have to subtract that being multiplied by that a. So we're really subtracting a times b over 2a squared. Well, let's simplify that. What is b over 2a squared? I give all those a square, so I'd really have b squared over 4a squared. And then what happens to a's here? This a would cancel with one of these a's, so I really have minus b squared over 4a. Okay, let's look at this here now. So down here, I got a plus x, or a times x plus, well, this guy right here, remember the half of b. So this is really b over 2a. And then on the outside, let's get a common denominator. So I have a c plus a b squared. Well, actually, it's a negative b squared, sorry. So I'm just going to put a minus sign instead. B squared over 4a. So I got to multiply this by 4a over 4a to get a common denominator. So I really have 4ac minus b squared all over 4a. So that's going to go in this spot right here. So 4ac minus b squared all over 4a. Okay, so that kind of helps us out. So the general form is like this, and we just derived the vertex form. And we should be able to tell, remember our vertex form is that x minus h plus k. Well, how do we find the h then? We could take, it's the opposite sign and then the b over 2a. So to find the x value of our vertex, we can just take negative b over 2a. And those of you that took Algebra 1, that might sound kind of familiar. So if you want the x value of your vertex, just take the negative b over the 2a. That's kind of nice. You could memorize this stuff too to help you find the y, but I don't like doing that. I would just much rather find the x, and then to get the y, I would just plug in the x value. Okay, that's much easier for me. So let's do that with one of these guys here. So let's just find the vertex. Well, we just proved that we can just take x, or we can just take negative b over 2a. Well, what's your b here? That would be negative 2. And what's your a? That would be 3. So all I got to do is take negative 2 over 2 times 3, which we'd get 2 over 6, which is really 1/3. So the x value of my vertex is 1/3. And to find the y, we just plug 1/3 into boop, this equation, our standard form. So our general form, whatever you want to call it. So 1/3 squared minus 2 times 1/3 plus 7. And we get 6.6 repeating, so 6 2/3. 6 2/3. And leave those as fractions if they don't terminate. It says, is it a maximum or a minimum? We'll just take a look. What's your graph doing? Is it going up or going down? Well, you have a positive number in front of your x squared, so that means it's going up. So that means your vertex is a minimum, right? Because it can't go any lower than that vertex. So that guy is a minimum right there. All right, sweet stuff. Last thing, what we can do with this, we're just going to barely touch on this. You do a lot more with this in pre-calc and calculus. But projectiles, those deal with parabolas, right? If I have something that goes up, it must come down because of gravity, which makes a parabola. So henceforth, we can use our quadratics for projectiles. And things that we need to know, the height from which it's thrown, that's important. Okay, the upward velocity, that's the important. And plus, we always have to consider gravity. So we have a nice equation for this. Okay, and this a that's in front of the x squared, that deals with our gravity. Okay, acceleration due to gravity. Okay, and we'll talk about what we put in for there. And the v sub o here, that's our initial velocity. That's like how fast it's going right when it gets thrown or hit or whatever was going on in our projectile. And lastly, this is our initial height. Because if you think about it, that's our y-intercept. So that's the initial height, which is right down here. The x is time. Okay, the x is time. And y is our final height. That's the final height of the object. Or, well, not the final, I guess, depending on what period of time you put in. Sorry, my fault. I guess if I wanted the final height, I'd probably put 0 in there because it'd be landing on the ground if that was our goal. So different things like that. Okay, anywho, time is measured in seconds. This is important. It's always seconds. That's due to gravity, okay, because we use specific velocity for gravity. Okay, height is always measured in feet or meters, and this has to be the case also because of our speed of gravity, our velocity of gravity. So here's the thing, and I'll give this to you when it comes to a test, is that if it's in meters, we're going to use negative 4.9 for our A due to gravity. That's our kind of our velocity of gravity when it's in meters. And for feet, we're going to use negative 16. Okay, so I'll give you that information when the time comes. You don't have to memorize. So baseball is popped straight up at 96 feet per second from a height of 2 feet. All right, so 96 feet per second, that's our velocity, our initial velocity. From a height of 2 feet, so that's our initial height, that SO. And it says, what is the maximum height, and when does it reach this height? All right, so let's think about this here. Let's go back and grab this guy. Y equals ax squared. And what are we in feet here? We're in feet. So what gravity am I going to use? We're going to use negative 16 for that A. All right, so we got y equals a negative 16 for the A, so ax squared. What else do we got in our information here? V sub ox, so velocity is in front of the x, which is 96 feet per second. And then lastly, we throw our initial height in there, which is 2 feet, right? So plus 2. And it says, when does it reach its maximum height? So let's think about this. So this is the ground. This is your dude that's hitting the ball. He swings his bat, and the ball goes straight up and comes right back down. Makes a nice parabola there. It's got a maximum height. Well, what is that of the parabola of that maximum height? Well, yeah, that's our vertex. So if I wanted to find the vertex really quickly, what could I do? Well, I could get it in vertex form, or really, I know that the vertex is just negative b over 2a. We just proved that. So all I have to do is take negative 96, right, the b here, and put it over 2a, and the a is negative 16. So 2 times negative 16. So negative 96 over negative 32, which gives us a positive 3. So 3, and what does x stand for? That's our time in seconds, so 3 seconds, and we want to find the height. So I got to plug that 3 back into my equation here to find how high it was after 3 seconds at maximum height. And we get 146, so 146 feet. And when does it reach this height? After 3 seconds, in 3 seconds. So there we go, just using that information. I mean, there's lots of things I could have done with this, but knowing that the x value of your vertex is negative b over 2a saves you a lot of time, and we just proved how that works.